How to graph an exponential function, example B. Sketch the graph of the following function. We have f of x equals e to the negative x plus 1. Now remember, e is a natural number, and e is about 2.718. So the first thing we want to do is identify the parent function. Use the helpful points and the asymptote. Well, the parent function is going to be f of x equals e to the x. So let's go ahead and start there. I'm going to do this one a little bit different from the last example. In the last example, we focused on the points and the math that was happening to those points. In this example, we're going to focus on the graph and look at the transformations as they happen. So we have f of x equals e to the x. And let's go ahead and create our t-table here. If we substitute in at -1, we get e to the -1, which is 1 over e. And that is about 0.36. If we substitute in 0, we get e to the 0, which is 1. And if we substitute in 1, we get e to the first power, which is about 2.7. Okay, as always, we'll go ahead and start with the asymptote. It is at y equals 0. And let's put some tally marks here to help us. Let's say this here is -1. This here is 1. Here we have +1, +2, +3. So first, we have that horizontal asymptote, y equals 0. Now let's look at -1, 1 over e, which is about here. There is -1, 1 over e. And next we have 0, 1, 0, 1, and then 1e, which is about 1, 2.7. So really close to 3 there. 1e. And now this green curve is the sketch of our parent function. So next, we're going to identify the transformation and analyze their effects on our parent function. Well, it looks like we have our first transformation here, which is f of -x. Remember, that is a reflection about the y-axis, meaning if we have the y-axis here, the x-axis here, it would reflect from side to side that way. And then after that, we'll have a vertical shift upward by 1 unit. So let's start with that negative on the inside first. All right, we have f of x equals e to the -x. And remember what that does, it reflects about the y-axis, meaning it's going to affect our x coordinates. Everything on the left-hand side of the y-axis will be reflected over to the right-hand side, and everything on the right-hand side will be reflected over to the left-hand side. So if we do that, that's not going to affect our horizontal asymptote. If it reflects over, it kind of just overlaps itself, and it doesn't really move anywhere. So we will still have our horizontal asymptote at y equals 0. Now let's look at these points. If this reflects over to the other side, that would be at +1, 1 over e. This point reflects over, that actually just flips on over to itself. So we still have that point there, 0, 1. And now if this point flips over to the other side, it will be at -1 e. So let's put some marks here. Here's 3. So at -1 e. And now we have this curve. Okay, so next, this whole thing is going to shift upward 1 unit. So we'll go ahead and end with that. And that is going to include our horizontal asymptote. So everything is going to be shifted up 1 unit. I might have to change our range here. So let's see what that's going to look like. Okay, so once again, we're going to start with our horizontal asymptote. That was at y equals 0, but it shifted up 1 unit. Plus c, everything went up 1 unit. So we now have our horizontal asymptote here at y equals 0. Okay, next, let's go ahead and start with this point here. This was 1 over e. So that first point is going to be 1 over e plus 1, which is about 1.36. We had 0, 1, that shifted up 1 unit, so now that is at 0, 2. And then we had 1e, that got shifted up 1 unit, so now that is at 1e plus 1, which is about 3.7. So now we have the graph of the function that we wanted to sketch. There we have it. So once again, we started with our parent function using our kind of basic points here, and then we took one transformation at a time, doing that reflection about the y-axis first, and then shifting everything up 1 unit. That is all.